Okay, in this video, right, you'll be introduced the idea of asymptotes, and later on you'll also be learning how to determine the equations of asymptotes for certain kind of graphs. Okay, so let's just introduce you a brief idea of two types of asymptotes. The first one, right, okay, let's take a look at the graph in A. Okay, this is an exponential graph, y equals to e to the power of negative x plus 2. Okay, so if you use your GC to sketch, right, if you key in the equation in the GC will give you the shape of the graph. And you should notice that as x becomes a greater value, okay, as x becomes greater and greater towards the right, can you see that the y value is actually like approaching a certain number? Okay, the graph is going flatter and flatter and flatter. So this line that the graph that is approaching is what we call the horizontal asymptote. Okay, horizontal asymptote. Bearing in mind that asymptotes are not shown on GC, so you will need to learn how to determine the equations of asymptotes by looking at the equation of the graph later on. Okay, now I just introduced to you a rough idea. Okay, so then how do you tell the examiner that you know that there's an asymptote to the graph? Okay, point number one, label the equation of the asymptote. And after that, please use a ruler and pencil to add in the dotted line to tell the examiner that this dotted line is actually the horizontal asymptote to this exponential graph. Okay, don't worry about how I know that y equals to 2 is an asymptote first, because later on in the next video, I will show you how do you determine the equation of the asymptotes by looking at the equation of the graph itself. Okay, so the thing that you just need to know is horizontal asymptote is obtained when as x approaches either the positive infinity side or the negative infinity side, you'll notice that the graph, the y value is actually like approaching a certain y value. Then that indicates to you that there exists a horizontal asymptote to the graph. Okay, so that's for horizontal asymptote. Okay, then now another type of asymptote that you need to learn is vertical asymptote. What kind of graph has got vertical asymptote? A simple example is your logarithm graph. Okay, logarithm graph has got vertical asymptote. Like I said, how do you determine what's the equation of asymptote? I will explain to you later on in the next video. Okay, so for now, just know how do I identify it, as in how do I draw it on a graph to show the examiner that I know that there's a vertical asymptote over there. Okay, so for vertical asymptote, right, as x approaches a certain value, in this case, right, as x approaches the value of -3, the graph is actually either going, okay, very large in terms of the y value, okay, is going negatively large, or sometimes in other graph, the graph will go very large in a positive y value, okay, but in this case, the graph will approach very large negative y value, as you can see from the graph. Okay, so if that's the case, right, then we will say that x equals to -3 is actually the vertical asymptote. So how do I tell the examiner? Same thing, I take a ruler and use a pencil to draw in a vertical dotted line. And then I label the equation of the asymptote, x equals to -3. So this is to tell the examiner, this logarithm graph has a vertical asymptote at x equals to -3. And when you're drawing the shape of the graph, make sure that your graph will approach the vertical asymptote closely, but it doesn't touch the vertical asymptote. Okay? So in short, graphs approaches asymptote, but it doesn't intersect my asymptote line. Okay? Okay, so that's that. So this is a general point, but if it looks too complicated to you, let's use example to bring out the point. Okay, so let's take a look at example 10. Okay, in example 10, right, I will show you how do we identify the asymptotes for different graph. Okay, so the first one is what we call the rational graph. Okay, in case you are not, okay, rational graph is spelled as this way, rational graph. Okay, rational graph has got vertical asymptote as well as horizontal asymptote. Okay, so first, how do I get the vertical asymptote? Okay, to get the vertical asymptote, right, you focus on the denominator, the factor in the denominator. Okay, so I have a factor of x minus 2 in the denominator, right? So what do? I just need to set the denominator to be 0 and solve for the x value. So in this case, I set x minus 2 to be 0 and I get the x value to be 2. So this will tell me that the equation of the vertical asymptote for this rational graph is x equals to 2. Okay, so take a ruler and pencil in exam, just draw a vertical dotted line and then label this to be x equals to 2 to be the vertical asymptote. Okay, then the next one, how do I identify the equation of a horizontal asymptote for rational graph? Okay, first thing, right, you need to make sure that this is a proper fraction. But x plus 2 over x minus 2, the coefficient, the highest power, okay, the degree of x is the same. So if the degree of x is the same, that means it's power 1, this is power 1, they are the same. That means this is improper, okay, this is improper. Because this is improper, you need to do a long division to make it proper. Okay, do a long division to make it proper. Once you have made it proper already, right, then the quotient itself will be my equation of a horizontal asymptote. So my quotient is y equals to 1. Okay, this is my quotient. This will tell me that y equals to 1 is my equation of the horizontal asymptote. So again in exam, I just take a ruler and draw a dotted horizontal line and then subsequently label it as y equals to 1. Okay, so over here we have also given you an easier way to identify. Okay, how do you get the horizontal asymptote? It's just y equals to, you take the coefficient of x in the numerator to divide away by the coefficient of x in the denominator. So that's how I get 1x divided by 1x to get me 1. Alright, okay, so at the start of this chapter, we have told you we always sketch graph with a smile, right? So A represent asymptote. Now I have sketched in the asymptote. The next thing I want is the shape of the graph. How do I get the shape? I use the GC. So second step, you go to the GC and key in the equation. y1 equals to x plus 2 over x minus 2. Okay, to remind you, how do you call this fraction? Press alpha. Alpha, I think it's F2. Okay, not too sure. If it's not, please let me know. I will come to you and resolve it for you. Alpha, no, the button next to alpha will do. Sorry, the button next to alpha. Okay, then you have a fraction. There's a fraction function in the GC. Okay, please alert your tutor if you're not sure how to find how to get the fraction function in the GC, alright? Okay, then next, press the graph button to sketch it. Press the graph button to get the shape of the graph. Okay, so you can see, right, asymptotes are not shown on the GC. That is why it's very important for you to know how to identify the equation of asymptote, and then you sketch on your paper first before you go to the GC. Okay, so now, right, we know that, oh, I have a vertical asymptote over here at x equals to 2, and I have a horizontal asymptote over here at y equals to 1. So when you're sketching on your piece of paper, make sure that the shape of the graph approaches these two asymptotes in these two regions. Alright, okay, so over here, let's try to sketch it in nicely. Okay, making sure that your graph really approach the asymptote, alright? So start near the vertical asymptote, and then just curve it down and go near the horizontal asymptote. But do not touch it. Okay, then be careful and take note of where does your graph intersect the xy axis. So over here, it intersect the x-axis at the negative x value and intersect the y-axis at the negative y value. So when I'm sketching here, I remind myself it must cut at the negative value. Okay, but if it's very difficult for you to like fit in the shape after you do the marking, then you can don't do the marking first, but just remind yourself that it must cut at these two regions. Okay, then start near the asymptote and curve it down and approaches the other asymptote. Alright, okay, so now I have the shape ready. The next thing that I need to have is maximum and minimum turning point. You look at this graph, is there any minimum turning point or is there any maximum turning point? Don't have, right? So it's not applicable to rational graph. Okay, I stands for intercept. Okay, I need to find the intercept, so I need these two, x-intercept and y-intercept. So please recall, how do you get the xy-intercept using your GC? Go to second, calculate, and then go and look for the zero function as well as the value function. Okay, make sure you bound it correctly. You should get your x-intercept to be negative 2, 0. And the y-intercept to be 0, negative 1. Do not copy my intercept blindly. try it out on your GC. You can pause the video and really try it out on your GC. So in case you cannot get these two intersect, right, you can raise your hand immediately and ask the tutors around you. Alright? Okay, then intercept is done. Is there any line of symmetry? For this graph, there isn't, so don't bother. There's no endpoint as well. Okay, so no more. So that's all. This is the completed graph. And lastly, of course, you want to label your equation of the graph. Y equals to x plus 2 over x minus 2. Okay, later on we will have more practice on rational function. Okay, next let's move on to the other type of graph. Now, this is exponential graph. Why is this an exponential graph? Because the variable x is at the power. That's why it's called an exponential graph. The more familiar exponential graph that you see is like y equals to e to the power of x. So, 3 to the power of x, half to the power of x, all these are belonging to the same family, exponential graph. Okay? Okay, so now let's focus on part B, y equals to 2 to the power of x. Okay, for exponential graph, right, in order to determine the horizontal asymptote, okay, exponential graph only has got horizontal asymptote. Okay, exponential graph only has got horizontal asymptote. To determine the equation of the horizontal asymptote, you look at the equation itself, and then what number is attached to it? Okay, does it have like plus or minus any other constant value? So in this case, there's nothing there, right? If there's no value there, then this is as good as telling you this is like plus 0. So therefore, the equation of the horizontal asymptote for this example will be y equals to 0. Okay, so over here, I also help you to indicate how to find the equation of the horizontal asymptote. In the form of the exponential graph, y equals to a to the power of x plus k. This k over here will give you the equation of a horizontal asymptote at y equals to k. Okay? So y equals to k, y equals to 0. Y equals to 0 is actually the x-axis, right? So you don't have to like draw a dotted line if it's on the axis. Okay? Don't need to. It's not necessary. You just need to label and tell the examiner you know that there's a horizontal asymptote on the x-axis, y equals to 0. Okay, so asymptote is done. Next, we want the shape. So you go to the GC and key in 2 to the power of x. Okay, after that, press the graph button. The GC will give you the shape. Okay, for exponential graph, right, the GC is slightly misleading because the GC show like it touches the x-axis, right? But like I have emphasized to you, the graph shouldn't cut the asymptote. So actually, I have an asymptote over here. The graph itself should start slightly above and then go up. Okay? So the GC can only give you a general shape of the graph, but there's a lot of things, there's a lot of information that are missing in there. Okay, so back here. Okay, copying the shape from the GC, I start near the asymptote and then I curve it up. Okay, so this is the exponential graph, y equals to 2 to the power of x. Okay, so asymptote done, shape done, A, S, M. There's no maximum or minimum turning point for exponential graph, so no need. Okay, then I-intercept, you have, right? You have a y-intercept here. So you press your second calculate function to ask the GC where x equals to 0, what is the y value? So in this case, the GC should return you 0, 1. Okay, then there's no line of symmetry and there's no endpoint. So that's that for this graph. Okay, the last type of graph that is you need to learn that has got asymptote is logarithm graph. Okay, so logarithm graph, right, has got vertical asymptote over here. Logarithm graph has got vertical asymptote. How do you get the equation of the vertical asymptote? Okay, you look at the equation, the expression inside the ln. Okay, this is ln of ax plus b. So to get the equation of the vertical asymptote, equate ax plus b to be 0. Okay, and then solve for the x value. So in this example, right, I'm going to equate x minus 1 to be equal to 0. So x minus 1 equals to 0. You solve it, x equals to 1. So the equation of the vertical asymptote is x equals to 1. So now, before you use your GC, take out your ruler and pencil to sketch in the vertical dotted line to indicate to the examiner, you know that you have a vertical asymptote at x equals to 1. Then the next step, go to the GC and key in y equals to ln x minus 1. Okay, then the GC will also give you a very misleading graph. It shows that it's hanging somewhere, right? Okay, but no. Okay, so take note. Okay, so first thing first, you know that there's a vertical asymptote at x equals to 1. Okay, graph doesn't start hanging somewhere. Okay, it always starts from like an extreme end. So in this case, right, the completed logarithm graph actually should start from the bottom, but due to resolution problem, it's like misleading for the display of the logarithm graph on the GC. Okay, so please write down as a side note, it's very misleading on the GC. Don't just copy blindly. We always need to start from the bottom end. Okay, and then logarithm graph just keep increasing. It shouldn't flatten as well. So actually, if you increase the window over here, you'll see that the graph is increasing very slowly. Okay, but it doesn't flatten. So what is wrong if you sketch this in exam? This is a negative demonstration. Okay, if you sketch in, copy blindly from the GC, you start halfway and then it go flat. Okay, this is 0 mark. Okay, there are 2 errors here. Number 1, the first error, how come there's nothing at the bottom here? And number 2, the second error, logarithm graph doesn't flatten in this way. Okay, it doesn't go flat because it doesn't exist. There is no horizontal asymptote. If there's no horizontal asymptote, I shouldn't like go flat, man. Okay, so these are the 2 errors that is given in a display in this GC. Okay, so back here to sketch the correct one. Okay, number 1, we know that it will take this shape going from bottom to the top, and then it will just keep increasing. Okay. Okay, then the next thing, I shouldn't, like you see, okay, marking point, I'm just telling you how the examiner mark. My x-axis is only until here, but my graph extended way ahead of my x-axis, so shouldn't do that. Either that, in exam, you extend your x-axis, or you shorten your graph. Okay, make sure that your graph ends around the end point of your x-axis only. Okay, so around here. Alright. Okay, then the next thing, again, there's an x-intercept, right? So go to your second calculate function. Go and look for the 0 function. Left bound, right bound, the GC should return you 2, 0 to be the x-intercept. Okay, so in general, these are the 3 graphs with asymptote that is in your syllabus. Now let's go more in-depth into rational graph. Okay, let's go more in-depth into rational graph. Just more example. Okay, so to determine the asymptotes of rational graph, okay, so like I shared with you earlier on, the vertical asymptote is easy. How come it's easy? All you need to do is pay attention to the denominator and set the denominator to be 0. Solve for the x value, that will give you the equation of the vertical asymptote. So in this example, I set x equals to 0. X equals to 0 is the vertical asymptote. X plus 2 equals to 0. So x equals to negative 2 will be the equation of the vertical asymptote for this graph. X minus 2 equals to 0. X equals to 2 is the vertical asymptote to the third graph. And lastly, x equals to negative 2 will be the vertical asymptote to the last graph. Okay, then the next one, how do you find the horizontal asymptote? Okay, so you can highlight, okay? Just set the denominator to be 0 to solve for vertical asymptote. Okay, now the horizontal asymptote. Okay, to find the horizontal asymptote, right, there's one very important thing to check is that you must make sure that your expression is a proper function. If it's improper, you need to do a long division. Okay, so if it's proper, right, if it's already proper, then you can safely know that the constant, the quotient that stands alone will be the equation of the horizontal asymptote, which I'll show you in a while. Okay, okay, so example over here. Okay, so x plus 2 over x minus 2 obviously is improper because this is x to the power 1 divided by x to the power 1. You can do a long division to make it proper. After you do a long division, my quotient is 1, my remainder is 4. Okay, this is the remainder and this is the quotient. We want the quotient. Okay, so y equals to 1 is the quotient, right? So therefore, the equation of the horizontal asymptote is simply y equals to 1. Okay, so earlier on in the previous page, we have also shared with you a shortcut. Okay, you can get the horizontal asymptote equation by just taking the coefficient of x in numerator to divide away by the coefficient of x in the denominator. So let me show you an example over here. Okay, so now we are focusing on the horizontal asymptote. Okay, so let me just erase all this vertical asymptote information. Okay, so first thing first, let's check whether is it proper or improper. This guy here, this is constant over x, so this is already proper. Okay, if this is proper, that means, right, I can write this as y equals to 1 over x plus a 0 quotient. So therefore, y equals to 0 is the equation of a horizontal asymptote for this graph. Same thing here, this is already proper, so I can say that the quotient is 0. So therefore, y equals to 0 is a horizontal asymptote. Okay, the next one, this is improper because this is x power 1 at the numerator and x power 1 at the denominator. So either you do a long division or you I power by taking the coefficient over here divided by the coefficient over here. So 1 divided by 1 equals to 1. So the horizontal asymptote equation is actually y equals to 1. Okay, this one is not in your syllabus, so you don't have to know how to get the equation of the asymptote. Okay? Okay, so now let's practice with a few more examples to make sure you can be very comfortable in finding the asymptote and sketching rational graph. Okay, so the first question when you see rational graph is always check whether is the fraction proper or not. So in this case, this is constant over linear, so this is proper. Okay, so take note, this is proper. This is constant over linear, this is also proper already. And then the last example, this is linear over linear. Okay, linear over linear means, oh, I have got an x term at the numerator and I have got an x term at the denominator. So that means this is improper. So you can either do a long division or you can I power the coefficient to get the quotient later on. Okay, so one by one, okay? Let's focus on A first. Okay, so for A, right, since this is proper, so we know that our quotient is actually as good as just 0. So therefore, the equation of the horizontal asymptote will be just y equals to 0. Then to get the equation of the vertical asymptote, equate the denominator to be 0. So x plus 2 equals to 0. Solving for x equals to negative 2 will be the equation of our vertical asymptote. Okay, XL-intercept, right, you can either use your GC to solve for it or you can solve for it algebraically. So in this case, if I want the y-intercept, it's pretty easy. Okay, to get the y-intercept, I sub in when x equals to 0 into the equation. I get y equals to 5. So the y-intercept is at 0, 5. There is no x-intercept in this graph, okay? If you try to solve for the x-intercept, you will not get any solution. Okay, so let's sketch in the asymptote first, alright? The asymptotes are y equals to 0 and x equals to negative 2. So y equals to 0 is just the x-axis. Label y equals to 0. X equals to negative 2. Use a ruler and a pencil. Draw a dotted line down. Okay, this is x equals to negative 2. Okay, then the next step, go to your GC. Key in y equals to 10 over x plus 2. And press the graph button to sketch the graph. So in this graph, you have to be able to identify your asymptotes that you have obtained by analyzing the equation. Okay, you have a y equals to 0 as well as a x equals to negative 2 over here. Then this will be how you are going to split up your graphs. Okay, your graph will be in the first and the third quadrant. Okay, so over here, and know how to, okay, so the graph will cut at the positive y-axis. I already know, right, at 0, 5. So when you're sketching, start near the asymptote and then curve it down and end near the asymptote. Okay, okay, then label, this is 0, 5. The next one, the third quadrant, start near the asymptote at y equals to 0 and then curve it down. Okay, that's all for A. Okay, then let's try B. Okay, so same thing, this is already proper. So therefore, the quotient is 0. So the equation of the horizontal asymptote is y equals to 0. Then for the vertical asymptote, set the denominator to be 0. So set x equals to 0. X equals to 0 is the equation of the vertical asymptote. Okay, if you try to solve for any x-intercept or y-intercept, you'll get no solution. So there is no x-y-intercept actually. Okay, then let's label, okay? Y equals to 0 is the x-axis. Oops. And then x equals to 0 is the y-axis. Okay, then the next thing, go to the GC, key in the equation. Remember, this is a negative sign in the GC, not the minus operator. Okay, otherwise you'll get an error message. This is a negative sign. Huh? Okay, then key in 1 over x. Okay, that the GC will give you the shape. So now for this graph, the graph is in the second and fourth quadrant. Okay, so like I said, due to resolution issue, right, the graph seems like it's stuck there. No, when you're sketching, please go all the way up and all the way down. All right, and it shouldn't touch my asymptote when you're sketching on your piece of paper. Okay, so it's in the second and fourth quadrant over here. Let's sketch in. Start near the asymptote and then curve it down. End near the asymptote, but it doesn't touch the asymptote. Okay, start near, curve it up, and then end near. Okay. Okay, then let's take a look at the third graph. Okay, so like I said earlier on, this is improper because there's an x term here in the numerator as well as the denominator. So you can either do a long division, which is shown here for you, or you can just I power. So how do you I power? You look at the coefficient of x. So the numerator is -3, the denominator is 2. So y equals to -3 divided by 2. This will be the equation of the horizontal asymptote. Then the next one is for the vertical asymptote. Equate 2x plus 1 to be 0. Equate the denominator to be 0. And try to solve for the x value. So x is equals to -12 is the equation of the vertical asymptote. Alright. Okay, then sketch in your asymptote over here. X equals to -12. Please use a ruler, okay? I'm drawing on a laptop screen. It's very slippery, so that's why it's not as perfect as I want it to be. Okay, then label x equals to -12. Okay, then y equals to -3 over 2 is below the x-axis. Use a ruler as well, and then a dotted line. Y equals to -3 over 2. Okay, then the next step, go to your GC and key in the equation. Y equals to 2 minus 3x over 2x plus 1. And the GC will give you the shape of the graph. Okay, so where are my asymptote? Is at -3 over 2 as well as -12 over here. So then I will know that the graph is in the first and the third quadrant. Okay, so first and the third quadrant. I need to know where it cuts. So take note, the graph cuts at a positive y value and a positive x value. Okay, so the graph, when you're sketching in here, it cuts here and here. But like I said, if it's very difficult for you to draw the shape after you do a marking, then don't do marking. Just remind yourself that the graph must cut these 2 points. Okay, then starting near the axis, starting near the asymptote and then curve down. The other one also start near the asymptote and curve down. Alright, then lastly, use your calculator to find the value of the x-intercept and y-intercept, or you can use your, just solve it algebraically. So this is 0, 2, and this is 2/3, 0. Okay, so that's all for this lecture.